So in this question, we are given the polar equation of r, which is r theta equals 3 theta times sine theta. And then we are given a graph here. And so in question A, we want to find the rate of change of x coordinate with respect to theta at point P. So it is basically dx over d theta at point P. So now we want to find out, we first need to know what theta is P at. And from the graph, we can tell P is when theta is equals to pi over 2 or 3 pi over 2. So we want to check if when theta equals pi over 2, r is positive. So here, at point P, theta is pi over 2, and r pi over 2 is 3 pi over 2. So we know that at point P, the theta is pi over 2. So, and we know x is equals to cosine theta times r. And when we plug the r equation in, we got 3 theta times cosine theta times sine theta. So dx d theta is the derivative of this equation at theta equals pi over 2. And when we plug it into the calculator, we got the value is negative 4.712. And in part B, we want to find the area of the region between the inner and outer loops of the graph. So it is like the area here minus the area of the outer loop minus the area of the interloop. So because we know the area is in polar is 1/2 integral r squared d theta, and now we need to find the from which theta to which theta is the inner loop and which theta is the outer loop. So at theta equals 0, r is equals to 0. And when theta is equals to pi over 4, r is this value. So we know it is going through one loop, but we don't know which loop it is. So we keep finding, and when theta is pi over 2, it is 3 pi over 2. And when theta equals to pi, r is 0. So we know it has completed one loop and then going to the other loop. And when theta equals to 3 pi over 2, r is equals to negative this. So because the absolute value of this is definitely greater than this, so we know after theta is equals to pi, it is going to the outer loop. So now we can find the area. So area equals 1/2 from pi to 2 pi integral of r squared d theta. This is the outer loop, and minus 1/2 from integral from 0 to pi r squared d theta, which is the inner loop. And plug it into the calculator, we got 139.528. So yeah. And in part C, the function r satisfies dr d theta equals 3 sine theta plus 3 theta times cosine theta. And for theta bigger than 0, smaller than 2 pi, find the value of theta that gives a point on a graph that is farthest from the origin. So it's basically finding the maximum of the equation r. So if we want to find this, we need to find the critical values, critical points of the equation. So to find that, we need to find when dr d theta is equals to 0. So here, when we find this equals to 0, we got points 0, 2.029, and 4.913, and 2 pi. So for each of these values of theta, we want to know what r is in order to find which r is the greatest. So after we finding the value of each point, we got r 4.913 is the greatest distance from the origin, which is 14.443. So at theta equals 4.913, our theta is greatest.